Problem 2 is about sending a signal through a noisy channel so that x1 becomes x2 after being transmitted through this channel, and xk becomes xk plus 1, and so on and so forth. And we're given the first probabilities of the first status of the signal, which can be 0 or 1. And probability corresponding to that are respectively 0.2 and 0.8. And for all k larger than 1, smaller than n, we're given this kind of a transition matrix, and we can immediately know that this is a Markov process. And we can see on the right, we drew a Markov chain to represent this whole process. Yeah, so if we're at status 0, for us to transition to 1, there's a 0.4 possibility, and for us to remain 0 in the next stage, we have 0.6. Yeah, and so on and so forth. And we can have a look at the first question, which is to find probability of when x2 equals 1. And so naturally we can think of where does this 1 come from? It can come from a 0 or it can come from a 1. So pretty much, yeah, we add those two possibilities together, and we can see that I wrote p x2 equals 1 equals p x2 equals 1 given that x1 is 1, and p x2 equals 1 given that x1 is 0. And yeah, basically we just need to multiply the probabilities a little bit, and then we can get a result of 0.592. And in the second question, we're asked to find out the probability when x3 equals 1. This is pretty much the same question from problem A, but we need to do a little bit more calculating, because to find the possibility of x3, we also need to know the possibility of x2, and then we can just because the status of x3 depends on x2, right? So if we can get the possibilities when x1 equals 1, if we can get the possibility when x2 equals 1 or 0, then we can do a further calculation. And here I found out the possibility when x2 equals 0, and that is 0.408, right? And this is pretty much okay. So I expanded the whole form. I took every scenario into account, but there's also a way to know this, which is to use 1 to minus this 0.592 possibility, because x2 in the x2 stage, it can either be 1 or 0, right? So we can see the 0.408 plus 0.592, and that gives us 1, which is correct. And from here on, we can know the possibility when x3 equals 1 is pretty much it can come from the last status being 1 or 0, and then we get this 0.5776. And problem C is for us to find the probability of x1 being 0 given that x3 is 1. Yeah, and then we can just we can know by the formula that we can know by the properties that the conditional probability is pretty much the joint probability of two scenarios plus the divided by the probability that is larger. that is the largest scenario, that is a given scenario. So here we have possibility of x1 equals 0 and x3 equals 1 happening at the same time divided by the possibility when x3 equals 1. We already found out that the possibility when x3 equals 1 is this 0.5776 number that we just calculated. And now we need to know the possibility of both x1 being 0 and x3 being 1. So pretty much here we're to say that x0 and x2 can be any value, can be 1 or 0, and we don't really care about those. And we're adding all of those scenarios together and find the possibility of that happening. So here we're doing a little math here, and you can see x2 is 1 or 0 and x0 is 1 or 0. And here finally we have this 0.324. And in the last problem, D, we're asked to find the limit of possibility xn equals 0 when x is infinity. So yeah, we have this. So from one state to the next state here is this. So what I just said, this transition numbers, they can make up a transition matrix. And every time we're actually just multiplying this matrix to get to the next stage. So if we have the limit, if there is a value that will converge to, then after multiplying the transition matrix, we have a1 minus a times this multiplied this matrix, and then it will give us the same value, a1 minus a, because this will be the limit. This will be the convergence, right? And then by doing a little math, we can find out a equals 3 over 7, which is roughly 0.4286.